I'd like to invite up our other presenters and also a couple of other panelists. David Funderburg from ABB, sorry. He's a technology manager for process automation. And Nasser Mund from Invensys. He's global director of modernization and safety systems at Invensys. Can I still say Invensys, or is it Invensys Schneider? Or, I don't want to say the wrong thing, but okay. I think we have somebody passing a microphone around as well. And I had a question somebody handed me here. We mentioned an ISA 106 paper tomorrow by Dave Emerson. The name of this session is actually, I think it's Reducing Operational Risk Through Procedural Automation. So it's not titled ISA 106. ISA 106 obviously is a big part of that session, and we do encourage you to attend that. But the name of the session is Procedural Automation. So I'd like to open it up to the audience. Do we have any questions from the audience to start off with? Yes. Yep, can't hear you.
Okay. Hi, it's Don Bartusiak, ExxonMobil Research and Engineering. So a question for Dave Garrett. The workflow that you described of legacy structured text to legacy functional spec to improved functional spec to new DCS code, is that a manual process or is there any automation in that activity?
There's an extremely high level of automation in that activity. That's the whole point of the case tools, but it's not totally automatic because we have that middle step where we want to take knowledge experts, process technology experts, and reform that legacy functional spec into a transformed functional spec. And there's two key activities we're after there, and I just hammer this home with all the guys. We're doing a physical model reorganization. We have to decide how to bundle up our equipment objects. Then we're doing a procedural transformation. So we're taking this older style sequence step map, which is for a whole unit and all the embedded equipment in that unit, and breaking it up into its component parts. And that takes a lot of knowledge. So we want to take some of that embedded intelligence and put it with the equipment objects, test and prove out those equipment objects, stick them in a library. Then we take the unit procedure, and I'm using S88 terminology here, and put that at the unit level. And then all the recipe stuff, because we never really had a high level of batch automation in these older control systems. So we want to take the batch component and put that in the recipe procedural part, and so on. So there is a lot of analysis and debate and work that needs to be done to take the legacy model over to the transform model.
So can you help me understand how much efficiency that you gained with the automation that you were able to use compared to a purely manual activity? And if I may ask one more question, can you give me some sense of defect count, or what was your quality control procedure by introducing automation for that activity?
Right, we're at the start of this journey, so I have to say, we don't really have a huge amount of data to throw out there on quality and so on. But from past migrations of old legacy systems to newer legacy systems, I can say I'll vouch just for those numbers that I threw up there from the SEI Institute, which deals with really working on these software product lines. So we want to drive the quality into those objects. So we take this little work process and we can use it to build up an equipment module, we can use it to build up a unit module, or to transform an entire CPU or entire controller. So I would say the quality is going to go dramatically up, and the testing will go dramatically down to the extent you can build up your libraries.
Thank you.
David, is this a tool you developed internally, or is this a supplier tool, these case tools that you mentioned? Or?
These tools are developed with our partner ABB,
Okay.
and basically we co-developed the ideas, and some of them also came from Yaya sitting here right next to me. Basically, it's just how to migrate structured text into a object-oriented environment.
That was going to be one of my first questions, was how would you migrate those many thousands of lines of code without going totally insane? But
that's why we want tools.
Yeah, yeah.
There's accounting tools that help us keep track of every code function in the old code and make sure we map those code functions to the new library objects.
Yeah, because in the past we've done research on that at ARC, and the batch side of things was always a particular focus area because you do have so many instances of these thousands of lines of code that's been built up over the years in the batch industry. And Anuka, I know you use some automated tools as well. Do you care to share your experience with how you found the use of the automated tools, maybe in a little more detail, or Yaya, maybe you could share some of your thoughts on automated tools?
So basically what we need to consider is, as it was mentioned before, Dow Chemical, the Mod 5 system, is not object-oriented, but highly categorized, highly efficiently divided into chunks. And therefore these chunks, otherwise we don't have 10,000 line of code running a plant. It's very organized fashion. Therefore, if you understand the organization and then moving it across to another organization is very simple. But we have been working, I guess, before Styron separate from Dow. Our teams have been, ABB, Styron, ourselves have been working together to figure out what's the best way forward. And what are the tools we need, what's the code accountability. And the difference is that these plants that we migrate, they are working before, and we need to make them work after. And we don't have that window of opportunities, just 2 or 3 weeks shutdown. And therefore, we are not like a greenfield project, come up and say, okay, this doesn't work, we will fix it on the next upload. It should work exactly the same or better than what we had before. Therefore, there's lots of software engineering involved, yes, to build above the object-oriented environment that we inherited or from ABB and the Mod 5 knowledge of what we have, how these codes are structured. Therefore, both of us are going through the path. As I mentioned, Styron is more batch-oriented than Dow. Therefore, Dow is more continuous-oriented than batch. Therefore, but I think the strategy we're going forward is very similar.
Anuka?
Yeah, I would definitely support the automation. I mean, obviously it makes a huge difference in time savings and just the amount of errors you're going to make manually. But the tools, at least in the case of Foxborough, I would assume every other vendor has the similar kind of tools where you can import your database into a spreadsheet type function and then pull it into your new system. I mean, all these tools are available out there. You just need to learn how to use them. So.
Would our supplier panelists care to comment on automated tools at all? Or?
Yeah, I'll add on to Mr. Garrett's comments about automating the process. And one of the key game changers that we looked at, we had talked about game changers this morning with Sandy Vassar on the hardware side, being able to touch the data once. One of the key objectives on the software development side to reduce our costs in software is to be able to develop a functional specification that's both human readable, so you can sit down with the process engineers and review the process, as well as computer readable. So when we develop a functional spec, we can read it and understand it and then get acceptance, and then we can also automate that. So we're reducing the number of keystrokes for every single automation control loop or sequence, and it's very advanced. So we're not talking about single loop control here. We're talking about a very high level complexity control system. So that's another key differentiator that we're trying to get to with tools with Styron, is to be able to have a functional spec that lives with the project. Get rid of the old way we used to do it. We'd build a functional spec and it was out of date before the plant even started up. So that's another key objective that the tools are focused on and support the workflow and architecture that Styron was discussing today.
Yeah, I just want to add, the object, like I mentioned in the presentation, is bundled with the simulation. So we have the functional spec, the simulation, and the object all in the database. And we can restructure, reform, copy strategies, edit, modify strategies from, say, one unit to the next, hit compile, let's say, and we get the application software ready to simulate in minutes. That's the goal. And the functional spec is always up to date. We've never done that before. They always are out of date first day of the project.
Excellent.
As Anuka mentioned, in our system, when Anuka is moving from one version to the other, there are automated tools, and that has always been the case because we invest quite a bit in keeping our systems continuously current, in creating a bridge between one level of our software and to the others, and there's always automated tools available to do that.
Excellent, thanks. Yes.
So this is a question for David and Yaya. Could you take us a little bit through the buy versus build decision process?
Buy as in buy what, and build as in build what?
Well, there's a few vendors out there that have solutions, advanced process control solutions. Is it that you felt that there was a competitive advantage for you to rewrite your own?
Okay, you're talking about procedural automation now? So, yeah, the idea is these equipment objects are basically fixed procedure. So we have, it's like the driverless equipment object, right? It starts itself up, it runs itself, it shuts itself down. So these are intelligent objects. But they're not huge. They're reasonably small, and they have what I would call fixed procedure. So we can set up these modes of operation and drive them from a higher level. And they trip themselves, go to the shutdown mode themselves. If you restart them, they'll go through the startup procedure themselves. And we can bundle that, version control it, and it's fixed. You know what you're getting with that object. So this is not advanced control, right? This is just equipment control. So adding that layer into our model from our old legacy model is quite a lot of work. It's not like for like anymore. And if you do decide to do that, you have to rethink your whole procedural model. And indeed, you'll have to rethink all of your advanced control schemes. And in ABB and in Dow, in the past, we had very advanced control schemes that we could put in the controller with, all kinds of levels of controllers working together to do a scheme. So in our company, for example, we only have a few examples of advanced process control that are up at a level above the controller, and that's on our big hydrocarbon Styron type plants.
If I can add, basically think about this, that in, for example, Dow Chemical, how many pumps we have. I think the work we did way back is about 14 type of different pumps we have. Therefore, either when you migrate the whole company across to a new platform, either you need to rewrite the pump every time you encounter a pump, or write 14 pumps. And then those 14 pumps, the way you write the code, the simulation, everything, is just done 14 times by experts and then used by the users. And they cannot change it. They cannot, our equipment modules cannot be changed on the fly. The parameters can change, but not the concept. The other thing that's very important for us has been that, and that's the change David's talking about, the Mod 5 code that we have today, the unit controls all of the instruments. Therefore, if you have a distillation, that distillation opens and closes all of the valve, all of the pumps, all of the equipment, all of the... But when we go with this concept of the unit module, equipment module, and then control module, now the distillation does not tell the pump what to do. The distillation just tells the pump, I want you to run. And that's a major improvement in terms of, therefore, we are dividing the works. We check a small portion of the code completely. When you put them together, it's a very sophisticated code, but all tested. Because our dilemma is that in a simplistic environment that we had Mod 5, you could see the whole thing, you can test it. When we go with these complex object-oriented environments, it's not that easy to see if somebody goes and types it. It's not very easy to see where is the problem. And we want to make sure that we don't have any problems in operating these units. Therefore, the challenge comes is when you have complex code, how many times you want to write that complex code. Using control module, equipment module, or unit module, procedural control allows you to just focus on your complex code and write it once and then reuse it a lot. Did I answer your question?
Yes, thank you.
We have one other question right there.
Hi, this is Venkat from PCN Technology. The question is for David, Yahya, and Anuka. The work that you described, how does that position you or get you on a path to whatever your corporate vision is for the industrial Internet of Things, being that that's a theme of these sessions?
All right, I'll
Good
start.
question.
Industrial Internet of Things, I think that's actually, we just want to migrate right now. So the Industrial Internet of Things, I think there are some things in my mind, like truck driver loading or packaging type things, where we can start to bring PLC type operations and who knows what into our control system. Right now we're just migrating the core.
The same comment.
Okay, in our case, we're probably the future vision would be to be able to pass data seamlessly from one system to another, use it for feed-forward variables, for being able to control the mill to the most cost-effective way, where you can pass information from your business system saying, right now, chemicals are expensive and energy is cheaper, and maybe being able to online adjust the targets of where these processes should be running to be able to run as cost-effective as possible.
Anybody else care to comment? We have I think we have one more question here.
Yeah. See, myself, Harish Tamboli from Reliance India. Just I was looking for that in case of the upgradation of the system, say for example DCS, ESD, of the huge plants having the IOs of 4,000 to 5,000 IOs. Now, how do you do that? How you handle that, the upgrade? You do the complete checking from the field device up to the system, or from the mastering cabinets? It's a very tricky question, and I don't see any standard for that, doing that upgrade.
Very good. That's the biggest challenge we have. The challenge is that our good-sized plants are about 12,000 IOs, yes, or average plants are 5,000. The challenge is that when we migrate, we do not want to have extra time down for the migration. Therefore, we are planning to migrate when they have a shutdown. They go down every 8 years or every 5 years, come back in 2 or 3 weeks. In the same period of time, we need to migrate. Therefore, the challenge becomes is how can you migrate an industrial size like a hydrocarbon 8,000 or 5,000 IO in 2 weeks. And you're moving the one computer system back and putting a new one. And that's why I'm going to back here next year or year after that to report to you how successful we have been. Therefore, everything's on the plan, but I will tell when I'm done. Therefore, I think maybe we'll check that.
Yeah, for Styron, we have some design software we only talked about today on the software side of things, but on the hardware side of things, we also have a database, IO. We design the cabinets, and then we pre-make all the master cables so that they're pre-assembled, everything's in place. We pull the old cables, plug in the new cables, and we test, some IO per cable, and we don't have to go through extensive loop by loop by loop, every single loop check.
Thank you.
Thanks. Well, we are at the end of the program today. I'd like to take more questions, but we may be better off just taking these questions offline at the event tonight. Do we have some details surrounding the event tonight? I think it starts at 6 p.m., right? We have the Fiesta starting tonight at 6 p.m. I'm not sure when it starts, yeah. I need my, okay, 5:30 to 8:30. So I'm holding you back from drinks right now. But let's have a big hand for our presenters and our panelists. I thought they did a great job.